Okay, today we're discussing about a complete oblique projectile. A complete oblique projectile. Why we have to study about an oblique projectile? That is, when a body is thrown with certain angle to the horizontal, what is going to happen? Let us see here. So now you are throwing a body with certain angle with the horizontal. Then what is going to happen? Here, why we have to study this one? Because you know that in military there are some tankers. There are some bomb tankers, we can say. This is a tanker, let us imagine. So tanker is having this type of funnel in which a bomb comes. So bomb will come and fall on the enemy. It is on the enemy. For example, enemy is coming from here. So bomb will throw with certain angle. I mean, tanker will throw the bomb with certain angle, and it has to fall exactly on the enemy. This is called as accurate bombing. So to know accurate bombing, if you are in military, navy, or air force, they have to completely study about oblique projectile. What should be the angle of the projectile, and what should be the speed of the bomb which has to move, which has to come out from the funnel of the gun here. Then all these things, if you want to be accurate in bombing, then definitely you have to study oblique projectile. It is very important topic for the people of navy, the people of what is said to be army, and so on. So they should know perfect knowledge about all these things. So now let us see what is going to happen now. So here the first thing is, this is the velocity with which the bomb is thrown here. And here you know that there is a resolution of components. What is the meaning of resolution of components here? For example, here, if a body is thrown with certain angle to the horizontal, if this is u, you know what is this going to be? This is going to be ux, and this is going to be uy. And this is a rectangle. This is a rectangle here. If this is uy, this is ux, this is also going to be ux. If this is uy, this is also going to be uy. If this is ux, this is also ux. If this is uy, this is also going to be uy. Then now let us see what is ux here. If you apply sin theta means opposite side uy by hypotenuse u, opposite side by hypotenuse. Therefore uy is equal to u sin theta. So we got the value of uy, which is taken as u sin theta. Then what is the value of cos theta? Here cos theta is equal to adjacent side, that is ux, and hypotenuse is going to be u here. Then if you want to find out ux, it is going to be u cos theta. Okay, so we got the values of ux and ui components. So with this you understand that if a body is projected with certain angle with the horizontal, then it can be resolved into two components. In horizontal direction, that is considered to be ux, which is called as u cos theta. In vertical component, it is called as uy, which is said to be u sin theta over here. So now let us imagine that when you throw a bomb is exactly at this position during the path. At particular instant bomb is at this place, let us imagine. That means at particular instant of time during the path of the projectile, bomb is in its path. It has not yet fallen down still. It is in air only, but it is at this position. Then how are you going to find out this distance now? So for this you need to draw one perpendicular here. You need to draw one perpendicular horizontally. You need to draw one perpendicular horizontally as well as vertically. Let us see what is going to happen here. So when you drop a perpendicular here, vertically and horizontally, what it is going to be, let us see here now. So this is uy, which is equal to u sin theta. Okay, this is going to be u sin theta. Now let us find out what is going to happen here. So ux is u cos theta and uy is going to be u sin theta upwards. Now we need to find out what is this distance y, and what is this distance x here. From here to here it is taken as x. So you have dropped the perpendicular on both the sides, let us imagine. Okay, so you have dropped the perpendicular. Here also it is making 90 degrees. So you have dropped the perpendicular. You need to find out what is the horizontal distance traveled by the bomb and what is the vertical distance traveled by the bomb. And what is this going to be? Okay, what is this going to be? You know this is going to be the position vector. So position of the bomb is here. So from the origin to this point, this displacement is represented by the position vector now. Okay, we need to find out what is the position vector. You know along the x-axis unit vector is I. You also know along the y-axis unit vector is j here. So unit vector is considered to be j. Then let us see what is going to happen here. It's very simple. You have to find out what is x. You have to find out the displacement traveled by the body along the y-axis. These two components you have to find out here. So this is just to understand what is the meaning of resolution of components. Okay. So if I rub this one for making a more space for writing the things here. So now let us discuss about what is happening here. So for that, first thing you need to find out is what is going along the x-axis. What is happening? What is going to happen along the x-axis? See, you have to understand one thing. Horizontally, along the x-axis, gravity is not going to act. Gravity always acts along the y-axis. Gravitational force always acts downwards. Okay, because it is acting along y-axis. Gravitational force is always towards the center of the earth. So y-axis has gravitational force, whereas the horizontally x-axis there is no gravity. So what I am going to say here is, in this direction there is no gravity. So along the g along the x-axis is 0, whereas along the y-axis gravitational force is present here. Along the x-axis gravitational force is going to be 0. Now we need to find out what is the displacement x. So you consider a general formula, s is equal to ut plus half at square. Okay, so let us replace the things now. You know horizontal displacement in this case, s is going to be x here and u is going to be ux, which can be considered as u cos theta. Then what is this a? A is going to be gx and that is going to be 0. Acceleration along the x-axis is nothing but gx, and as there is no gx, it has to be considered to be a 0. Then if the data is to be substituted here, what are you going to get? X is equal to u cos theta plus a 0. This part is going to be 0, and here t is present. So t is present. You need not take this 0 also, because 0 it is right side. This half at square is going to be 0 because a is equal to zx is equal to 0. Then from this you need to find out x by u cos theta. You got the value of t. Now t is equal to x by u cos theta. Let us consider this is to be in equation number 1. Let us consider this is to be in equation number 1 here. So we got this one, and you have to remember that x is equal to u cos theta into t. You have to remember this one also. Now let us see what is going to happen now. Here we shall discuss what is happening along the y-axis. What is happening along the y-axis here. So if you are going to consider y-axis, you need to write the same formula, that is s is equal to ut plus half at square. Here along the y-axis you need to consider s is equal to displacement y. Then u is equal to uy, which is equal to u sin theta, and a is equal to gy, which is considered to be minus g. Why? Because you are throwing a body upwards, making certain angle with the horizontal. As you are throwing a body upwards, making certain angle with the horizontal, a is considered to be minus g because you are moving against to the gravitational force. Then what is going to happen? Let us see. Is the data, if you substitute here, you will be getting y is equal to, uy is nothing but u sin theta into t, as usual you are going to write, and half at square is nothing but a is going to be minus g. So here you are getting minus half gt square. So this is equation you are getting. Let me mark with the red pen here this equation as well as this equation. Okay, so you can take this equation as 1, okay, this as 2, and this is an equation which is considered to be 3. Let us imagine this is going to be 3 here. So now you have to further move. Let us see what is going to happen here. So now you just do one thing, substitute 1, there is substitute 2 in 3, substitute 2 in 3. You have to substitute this value in this equation. Then let us see what you are going to get. What you are going to get here. So you need to write like this, substituting 2 2 in 3, you'll be getting y is equal to u sine theta. Instead of t, you are going to write this value. That is x by u cos theta here. Minus half g t square. So t square means this whole square. This is going to be x square by u square cos square theta. You got this value. So from this you will cancel out u and u. Therefore, sin theta by cos theta is going to be tan theta into x minus half g. So you do one thing. Take x separately. X square you write separately. The remaining values you are going to write like this. 2u square cos square theta. Okay. So these are the values you have written. Now, this is of the form y is equal to ax minus bx square. This is of the form ax minus bx square, which is the equation of parabola. This is an equation of parabola. Kya bola? This is an equation of parabola. Then here, then what is going to happen? Let us see here. The value of a, where here, value of a is going to be tan theta, and value of b is going to be g by 2 u square cos square theta. Then let us see what is going to happen. So you have to substitute these values, then only you get this equation. A and b are going to be constants. Okay, what are these things? These are going to be constants here. These are going to be constants. So this is the equation. What you have done here in the first case, you have thrown a body with certain angle, and that is going to be a projectile. It is going to be a projectile. And we have proved that the path of the projectile is a parabola. How you have proved? In mathematical equations. This type of equation you are getting, that is ax minus bx square, then it is the proof. It is a practical proof that the formula which you are getting is a parabola. Now hence we have proved that the path of the projectile is a parabola. That is prove that path of the projectile is parabola. It is going to be a parabola. So we got the path of the projectile is going to be a parabola. Then the next thing you have to find out is what is this position vector. Let us imagine this position vector is p bar. How are you going to find out this position vector? Now p. Okay. So for that, let us consider the separate diagram here. For clear understanding, let us take a separate diagram. You take this one. You take this diagram here separately. So I have taken this diagram. This is a dotted line here. Let us imagine this is a dotted line. Separately I have taken. And now, during the path of the projectile, the body is at this place. I have considered this to be a position vector, p bar. Then, as unit vector is I here, unit vector in this case is j. So these are going to be the unit vectors here, I and j. Then this part is considered to be x into I, because this is the length which is taken as x. So this is considered to be x into I. Now, this part is going to be y into j. This is x into I, and this is going to be y into j. Understand? Then if you want to write the position vector, what is the meaning of position vector here? Position vector is nothing but x into I plus y into j. Why are you going to write like this? I'll give one small example to make you understand here. For example, there are two vectors. This is 4 meters along the I unit vector, and this is going to be 3 meters along the j unit vector. Then this is completely considered to be 4i, and this is completely considered to be 3j. So, and what is the resultant here? Here, the resultant which I am going to draw here, that is, this is unit vector I and j. This is going to be the position vector. What is the meaning of position vector? When a body has traveled 4 meters towards x-axis, and it has traveled 3 meters towards y-axis. So its initial position and final position, the straight line is giving the position vector, and that is going to be the displacement. When a body has traveled 4 meters along the x-axis and 3 meters along the y-axis, what is the meaning of the position vector? The starting position, ending position, and the straight line is going to be the position vector. Then this is 4i and this is 3j. Now you are writing this as position vector p bar is equal to 3i plus 4j, sorry, 4i plus 3j. You are writing first here 4i plus 3j. This is 4i, this is 3j. So this is called as a position vector. Understand? Okay. So let us see what is going to happen now. But in the case of magnitude, what are you going to do? If you want to find out the position vector, here position vector is nothing but the hypotenuse. What are you doing for finding the hypotenuse? You just write 4 square plus 3 square, which is equal to under root of 25, which is going to be 5 here. So 5 is the hypotenuse here, 3, 4 and 5. Why? Because this is 90 degrees. This is 90 degrees. This is 90 degrees because I told you, you are dropping a perpendiculars there and here. You are dropping a perpendiculars there and here. So this is going to be the position vector now. Here, you are going to find out 4 square plus 3 square. But in terms of vectors, how are you going to find out the magnitude of this P bar? Magnitude of this P bar is nothing but, you'll write the step like this. In terms of vector, if you want to find out the magnitude of P bar, you just do 4 square plus 3 square. Coefficient of I square plus coefficient of j square, that is 3 square. And the same thing you are getting, the 5 value you are getting. So this is called as a position vector, which represents the position of the body. That is 4i plus 3j. Now, but here x as I have taken as 4 and y I have taken as 3. But in this case, x is going to be u cos theta into t and y is going to be u sin theta into t minus half gt square. Then you just substitute the values here. Then you will getting the position vector. What are you going to do now? X in the place of x you will write u cos theta into t, u cos theta into t, and you will take it as I. And y means you are writing u sin theta into t minus half gt square into j. U cos theta into t, and this is going to be the position vector. It is same as 4i plus 3j, but 4 is the magnitude here in this case, and u cos theta is a magnitude in this case. So u cos theta into t is the magnitude here, and this y, the magnitude is represented like this. But how are you going to find out the magnitude of this P bar? So simply you have to make a square root of all these things. So u cos theta whole square plus u sin theta into t minus half gt square. Okay, so half gt square whole square. If you do this thing, then you will get a magnitude of this, a position vector. What is the meaning of this position vector? I think you understood now. What is the position of the bomb from the origin is called as a position vector. What is the position of a bomb from the origin is going to be a position vector. I think you understood this one. Okay, so this is the concept here. Okay, friends, the next part of this session is going to be what happens to the velocity during the path of the projectile. What happens to the velocity during the path of the projectile? Let us see here now. Let us enjoy the session here. Let us enjoy the session. Physics is very interesting. You have to become a mad of physics. Let us see here. What is the concept? Let us see. So now, during the path of the projectile, when you project the body with certain angle at this place, making theta with the x-axis, then you are going to observe one thing. I told you that in the horizontal direction, g is not present, g is 0, whereas in the vertical direction, g is going to be present here. G is present in the vertical direction. Horizontally, g is absent because acceleration due to gravity always acts vertically downwards. Vertically downwards. So if you observe from the left side, you see one thing. As you project the body with certain velocity, as you go up, u cos theta vector size is same. Here also u cos theta only. Here also u cos theta. The size of the vector along the x-axis is going to be same. Okay. But if you observe the size of the vector along the y-axis, it is slowly reducing. This is a little bit more. As an angle is less, it is going to be decreasing. Here decreasing. As the angle is decreasing, because as you move from bottom to top, you will see one thing, that angle is going to decrease. As the angle is going to decrease, y component is also decreasing. The state, which is called as, this is going to be the maximum height. This is going to be the maximum height here. At this position, there is no u sin theta component because this angle theta is going to become 0 here. Only horizontal component is present, whereas vertical component is going to 0. Understand? It is going to be 0 because sin 0 is 0. U sin 0 is 0. So at the topmost point, u sin theta component is not present, whereas u cos theta component is constantly acting from starting point to the ending point. From starting point to the ending point, u cos theta, u cos theta, u cos theta, u cos theta, u are going to be same. So that's what I am saying here. This is going to be same here. Now, let us imagine you want to find out, you have to find out at this particular point during the path of the projectile. At this particular point, you have to find out instantaneous velocity. What is the velocity at this place you have to find out. How are you going to find out this v? For that I will explain you how are you going to find out this v here now. Let us consider this is the horizontal component now and this is the vertical component now. Okay, so now how are you going to find out the instantaneous velocity at this place? Let us imagine this is going to be instantaneous vi, which is making angle theta with the horizontal. Just now I told you in the horizontal direction, what is the final velocity? Vx is the final velocity in the, that means here at this place is the initial velocity. During the path of the projectile at this place, instantaneous velocity is going to be the final velocity at that particular position. Okay, we need to find out instantaneous velocity. Means a velocity at this particular point we need to find out. What are you going to do for that? It's very simple. You have to find out what is Vx and you have to find out what is Vy here, vertically and horizontally. So for finding this, you can take a general formula. What is the general formula? You know V is equal to U plus AT, but along the x-axis if you are considering, that is, you need to consider Vx is equal to Ux plus Ax into T. I told you Ax is equal to Gx and Gx is not present horizontally. Just now I mentioned there. Then let us see what is going to happen now. Then you will understand that Vx is equal to Ux and that is always going to be U cos theta. I'll write a little bit larger size so that it is. So Vx is equal to Ux, which is considered to be U cos theta. And what is Vy? That is our question here. So Vy, that is our question. Let us imagine this is the initial velocity at this place. So at this place, initial velocity if you consider during the path of the projectile of the second half, if you observe. So let us see what is going to happen. So now you got the value of Vx. You just now got the value of Vx. Okay. So I'll write you here. Vx is going to be U cos theta. That's it. G part is not present. This right side part is not present here. This is happening along the x-axis. Then what is happening along the y-axis? That is our question here. So the same old formula you are going to write. V is equal to U plus AT only you'll write. But as it is in y-axis, you can write Vy is equal to Uy plus here. Okay. Ay into T. That's it. So let us consider one thing here. Ux is present at this place, that is called as U cos theta, and at this place if this is the starting point, this is the ending point during the path. Let us imagine this is the final point, this is the starting point. So Ux is going to be U cos theta. Just now I told you at the highest point U cos theta is present, whereas Uy is equal to U sin 0, which is going to be 0 here, 0, because in the horizontal position this angle theta slowly decreases. Here it is maximum. As you go up, so angle theta slowly steeper. Here it is going to become 0. That means this vector and U cos theta both will join together, become only single vector. That is going to be U cos theta. That's it here. So this is the concept here. Now let us see what is going to happen, the further thing here. So as Uy is going to be 0, then you can write Vy is equal to, or else if you want to can take in the general case. So total velocity if you consider, if you keep Uy also, what are you going to get now? If you keep Uy at the highest point, it is going to be 0. For example, if you consider this as the initial position and this as the final position. If you start from here, Uy is going to be 0, but if you start from here, Uy is present here. Uy is present here. That is, Uy is nothing but U sin theta. Let us imagine you are starting from here. This is the first point and that is the second point. If the situation is changes from here, this is going to the first point, that is going to the final point. So how are you going to find out Vy? y. Okay, so for that you will just write uy. Uy is nothing but u sine theta, and I am going to consider this as Vy, know that position. So it is coming down. It is coming down if you imagine. But if you consider during this path, you are considering during this path, here at the first position it is going upwards. So you can consider this as minus g into t. Okay, minus g into t. Why are you writing gt here? Because ay is equal to minus g during this path. Okay, so this is happening here now. U sine theta minus gt. If you consider this as the first point and this is the second point. Okay, that's it. So this is Vy point. This is going to be the magnitude of Vy. So you got Vy value, you got Vx value. Then how are you going to represent this vector now? Let us see. How are you going to represent that vector now? Here, let me write here separately. So I will close in the form of a rectangle this part. This is a dotted line. Now I am going to find out this as an instantaneous velocity. So this is downwards, this is right side, this is going to be minus, this is going to be Vx. Can you write this as Vy? Because it is down. It is down. Okay, so now this is, for example, Vi, instantaneous velocity. You can represent this as Vx in this direction, but here unit vector is I, unit vector is j downwards, but it is negative and is coming down. You will consider this vector as negative. Can you write this as Vx into I minus Vy into j? Yes, you can write, because this is downwards. Upwards, if it is there, it is positive, but downwards according to the coordinate system, this is going to be negative. Then instantaneous velocity is Vx, and Vx is nothing but u cos theta into I minus, what is Vy? Vy is nothing but u sin theta minus gt here. Okay, u cos theta, this is u cos theta into I, and this is u sin theta minus gt into j. Okay, so let us write here, this is going to be j here. So this is Vi, and this is going to be instantaneous velocity. Now this is going to be instantaneous velocity. So we got the formula for instantaneous velocity. The formula for Vi is this one. Why is it that? Because Vx is equal to u cos theta, because gt part has gone. Same old formula you are using in both the cases. Same formula you are using both the cases. Horizontally, always this part won't be present, but vertically u sin theta is present, minus gt is also present here. Okay, so therefore you are just substituting the value of Vx and Vy, then you are getting instantaneous velocity at that point. But if you want to find out the magnitude of instantaneous velocity, okay, as I told you, if you want to find out the magnitude of that, you need to write just Vx square plus Vy square from this. Okay, so anyhow this is positive, one is positive, one is negative. So minus, you can write like this, plus of minus Vy whole square is anyhow going to be plus only. So here V in instantaneous velocity is going to be Vx square. So what is Vx value? I just told you Vx value is u cos theta. So you can write this as u cos theta whole square plus Vy. Anyhow minus of minus into whole square is going to be positive here. And Vy value are going to write this u sin theta minus gt into whole square. So this is the final formula for the instantaneous velocity. I am finding the magnitude of instantaneous velocity also at this particular point. Okay, hope you understood this one. Okay, it's clear, I think. So this is about the story of a parabolic path.